Alright, so what I'm going to do right now is a quick little calculus tutorial to do with profit, revenue, and cost at the request of a friend of mine. So here we go. Well, we have these three words written down on our paper to kind of start everything out, and the three words we have are profit, revenue, and cost. So the first thing you definitely need to know is the relationship between these three things, what they are. You shouldn't need someone to give you a formula to kind of figure out using context clues what everything is. So if you've ever done a lemonade stand, if you've ever, sold something to someone and overcharged them for what it cost you, even as a kid, I don't know, I'm sure there's been cases in your life where you've been a businessman or a businesswoman. So what are all of these things? Costs, a lot of times what we might think right away is what it costs you to buy something. Oh, the cost of that shirt is blank. But in the business world, the cost is what it costs a company or a person to buy the things that they need when they're on their little endeavor. Okay? The revenue is the money that comes in. The cost is the money that goes out. And then the profit is what remains. So when you have profit, obviously you want the revenue to be bigger than the cost, because if you are making less money than you're spending, you're going to be upside down. You're going to be negative. You're not going to have profit. You're going to be in the hole. Okay, so we have a ton of expressions out there. So what is your relationship between these two things? Well, or three things rather. Profit equals revenue minus cost. Now you don't always have to write out the full words. We can write it using function notation. But when you use function notation, it's going to look something like this. P of x equals, it's not px, it's p of x. So it's basically telling you the profit with respect to x. Now I'm sure that there's many ways that you might choose to interpret this, but x might be the number of units you are going to be producing. Okay, so x being the number of items or the number of units, so cups of lemonade. All right, your cost is going to be the things you buy. You're buying cups, you're buying the lemons, you're buying sugar, you're buying a pitcher, you're buying the materials to make a sign, the materials to make your lemonade stand, the materials to advertise. Your revenue, well, if you're charging 25 cents a cup, your revenue is 25 cents times the number of cups of lemonade. X is the number of cups of lemonade. So the cost is in relation to how many cups of lemonade we're going to be working towards producing. If you don't make enough cups of lemonade, you run the risk of, missing out on possible profit. But if you make too much lemonade, you could be wasteful and end up throwing it away. So there's a lot of balance that goes into this. And then your profit is the money that's left over at the end of the day. So x in this case is you have to define it to help yourself write your equation sometimes. So P of x, the number of items, the number of cups of lemonade, whatever it is equal to R of x, the revenue, minus C of x. Now, just a little curveball to throw out there. You don't have to default to just this. Any rearrangement of this could be true. That doesn't mean you just swap things. But say I wanted to get R of x by itself. If you wanted to isolate R of x, you don't need it to be on the left. R of x could be alone right over here on the right hand side, so I'm going to bring C of x over. Using algebra, you bring C of x over. Well, that gives us then, don't mind the green marker on my hand, I had a broken marker. So R of x will be alone. It's on the right, but I'm writing it on the left. So R of x will equal, I add that to the other side using algebra, so it's P of x plus C of x. So that's the same exact relationship rearranged. It's just another perspective, okay? And third, what about C of x if I wanted to get C of x by itself? Now if you go here, it's negative in front. You can't forget that. Here, it is positive, so it's a little easier to look at. If it's already positive, you just bring this over now. So now C of x is going to be alone. Cost will equal, the R of x was on the other side already, and minus P of x. Obviously these might be harder to understand. Your cost is equal to your revenue minus your profit. Your revenue is equal to your profit plus your cost. But if you take a few seconds and think about it, you can definitely get a grasp on it, okay? Let's say that you are in a situation where a word problem was starting things off by giving you the revenue and the profit. Couple things: using your intuition, problem solving, test taking strategies you need to instill in yourself. Even if your professor or your teacher only gives you, hey guys, just so you know, profit is equal to revenue minus cost. You know, they don't give you any backstory, they don't really justify it, they just tell you, can you please know this? Cool, thanks, let's move on. Even if that's the case, you should, no matter what, even if they told you, you know, puffies equal Ridgies minus Crunchies. I have no idea what the heck that even means, neither do you, but you're like, got it, it's an equation. Every rearranged version of that same equation will also be true, okay? You're just solving for a different variable or a different value. So if a word problem starts off by basically identifying for the reader or the problem solver with the revenue, they're like, hey, this is revenue and this is profit, you could pretty much guarantee that the question is going to ask you to solve for what? Hopefully you said cost, because it's going to be a little too easy if you're in calculus and, oh, tell me something about the revenue. It's like, cool, you already gave me the equation. Or tell me something about the profit. Got it, you already gave me the equation. Let's be a little, you know, more intense than that. So let's say they gave you that the revenue is negative 4 x plus 9x squared minus 168. And let's say that the profit is negative 4x cubed, negative 4x cubed plus 80x. So someone figured it out, you hired someone, they did it for you. And now the problem is going to say to you, yada yada storyline, you have a lemonade stand, this was your profit, but this was your revenue, how much money came in, but someone didn't keep the receipts and we don't really know how much money you spent this week. So we'd really like to know, or this, you know, today. So we'd really like to know what was the cost for the day. So we're going to work backwards, and then we're going to also figure out, you know, like what would minimize the cost. Okay. So if we want, because obviously you're not trying to maximize the cost, right? You want to maximize revenue, you want to maximize profit, but you don't want to maximize cost. You want to keep your cost down. So the word problem in so many words is basically going to ask you to minimize cost. And if you could figure that out in your head before you even read the rest of the problem, it makes reading the problem much easier, because you can read between the lines. You could totally see through it. So if you know, someone tells you ahead of time, oh, so-and-so's going to come up to you and they're going to give you this whole song and dance, they're lying to you. They're going to give you this whole story to try to get you to invest in their pyramid scheme company. Well, now when they come up to you, you're ready for it. Okay, you're going to catch the little things that they're doing, the manipulations and this, that, and the other thing. So you want to be prepared for that. So we want to minimize cost, and we're also going to use this equation right here. So C of X is equal to revenue minus profit. Now it's important, here's revenue. I'm going to overuse my parentheses, so negative 4x plus 9x squared minus 168 minus the quantity of, okay, got to use parentheses, negative 4x to the third plus 80x. Okay, let's not try to be a hero. I'm a math teacher and I've been teaching math for 13 years, 4 years in college and years of math growing up, and I show my work. So don't try to be a rock star, show your work. I feel like I actually understand so many things in math better because I have to constantly show everyone else how to do it, that I write more down and I feel like I have a deeper understanding of what I'm doing. So you should definitely do the same. So I'm going to open up my parentheses, negative 4x plus 9x squared minus 168. Now, minus negative, well, minus really means opposite, and the opposite of a negative is positive. So this becomes plus 4x cubed. There is no 4x cubed here, so I'm going to write it right there. These are just little things I do. Minus a positive 80x, well, it means the opposite of 80x, which is negative 80x. I'm going to write it underneath here. I like to go a little vertical sometimes to save some space, and then I kind of look at it like a vertical word problem. So that means I have the cost function is. Now while I'm adding, now there's not that much to combine, I'm also going to put it in descending exponential order, so biggest power in front. 4x to the third plus 9x to the second minus 84x minus 168. Okay, so now that's my cost function. Well, we're being asked to minimize this cost. We want our cost to be as low as possible. Now, read between the lines. I know there's lines all over this paper, but literally we gotta really read deep into it, okay? When you're asked to minimize costs, you're gonna wanna know, well, what value of x are we gonna be dealing with? And what will c of x also be? X is gonna be number of units. Now maybe it's the number of units produced per week, per day, per month, per year. Maybe it's cups of lemonade. Maybe it is flat screen TVs. Maybe it is computers, couches, whatever it might be. So you have to read the problem to know what it is. Does it matter? Not really. So if you were doing a problem in another language and you only knew a few of the words, you could probably still figure out what to do. And then c of x is obviously going to be your cost function. But it's cost with respect to x. If we produce 100 items, it'll cost us this much. If we have to produce 1,000 items, it'll cost us this much. Sometimes costs go down when you produce more because you can save money by opening the factory once and just getting it all open. Sometimes it costs more money to close down the shop and reopen and yada yada. So you have a lot of different factors. So this is going to be the cost. So in this case, it'll be a minimum cost, but with respect to x. So when we want to minimize in calculus, we use something called the derivative. And what the derivative does, if we even look at this, it's 4x cubed. It's a cubing function and it's positive. It might look something like this when all is said and done, and that's from algebra and even pre-calculus. You learned about this. Now maybe it's not as loopy, maybe it's a little less extreme. Maybe it looks like this. If it looks like this, it could have 2 turning points if the biggest degree is 3, and it could have up to 3 zeros, which are the x-intercepts. It could look like that. It could also look like this though. Here I don't really have any turning points. Okay? I might only have 1 0. It's not really any way to avoid an x-intercept because one side's pointing down and one side's pointing up. So I already know certain things about this polynomial, which is great. Now, minimum cost. I know I'm looking for this value. I'm going to get an x value and another x value, and I'm going to want the bigger x value because that'll give me the smaller cost. Your graph, whatever way it's all said and done, I'm sorry if that's so crooked, when your graph is all done, the cost is going to be, it's your y value, it's on your y-axis, it's your output, and your x value, well, your input is the number of units, and that's on your x-axis. So I know, because I know the graph, I know the picture, that this will give me a minimum cost, and this will actually give me a maximum cost. You would have been better off not producing any items. Okay, you would have had, certain situation. Obviously this graph is not right, but now, what are we going to do to figure out where these are? We really have learned how to take a derivative. A derivative finds you the slope. The slope is really the slope of the line that is drawn tangent to the curve. So if I can find a derivative, I can find slope. What slope values are going to be really significant? In this example, it's going to be really significant when the slope is 0, because that's where we change directions. That's where you go from going up to being horizontal to going down to being horizontal to going back up. That's where it changes directions. Now here you might have a horizontal tangent line, but it's kind of a little fake out. It's like you're going up, 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 up. You get here, if you're blindfolded and on a roller coaster, you might think you're about to drop. But it's like, okay, just kidding, we're going to go back up again. Whereas here, you got that feeling in your stomach, you know you're at the top, you are going to drop. So it's not always a max or a min when you get that feeling. You have to continue. So next step, here's my cost. I'm going to take a derivative. If you don't know how to take a derivative, this video is not for you. Okay? If I take the derivative, I'm going to have 12x cubed. Don't listen to me. Sorry, squared. 18x minus 84. And if I want to know where I have a horizontal tangent line, I want to know when my cost derivative, when my rate of change of my cost is equal to 0. Now these are all multiples of 6. So I can actually, because it's equal to 0, I can actually divide everything by 6. You could do that when you have an equation equal to 0. I'm going to make smaller numbers. So I have 2x squared plus 3x minus 84 divided by 2 is 42, divided by 3 is 14. Sorry, my dog's here now, so we may hear noise. Okay, got this guy right here. Now, next thing is, this is a quadratic, or a parabola when you graph it, and I want to know when it equals 0. A quadratic looks like this, and it can equal 0 in up to 2 places. You get those 2 answers with factoring. If you forget you have to factor, this is the thought process you have to have. Okay, now factoring. Factoring is the opposite of, or inverse really, of distributing. Okay, it's like the kryptonite to the Superman. One counteracts the other. What multiplies? So first times first gives you this, last times last gives you this, and then the outer and the inner, does this ring a bell? Gives you that, right? 2 is prime, it's the only even prime number. What multiplies to give you 2x squared? 2x and x. What multiplies to give us 14? We could do 1 and 14, 14 and 1, 2 and 7, 7 and 2. But I need my outer and my inner to make 3. Okay? Now, if I use 14 and 1, probably not going to put 14 here because those are 2 evens. If I did 14 here, I get 28 and 1. That's definitely not going to give me a 3. 7 and 2 looks more promising. If I had a 7 and a 2, 2 could go here and 7 can go here. My outer, I see a 4x, and my inner, I see a 7x. How do I get a 3x from that? Well, if I have a positive 7x and a negative 4x, I'll get a positive 3x, and that's definitely what I want. How do I get a positive 7x with a plus right there? How do I get a negative 4x with a minus right there? Okay, factoring 101, I hope we all know how to do that. Then what you do is now you have linear factors. We're going to use something called the zero product property. So when you have something factored and equal to 0, you set each of those factors equal to 0. So if I do that, I get 2x plus 7 equals 0. That's going to get me one answer, and I get x minus 2 equals 0. You never do this unless this number is 0. I don't know how many times in my life I've said this, but it's worth saying again. It's called the zero product property, not the 10 product property. So you get 2x is negative 7, so x is negative 7 over 2, which is probably a throwaway answer because you're not going to produce negative 7 over 2 units. And then here we get x equals 2. Beautiful. Now you're not always going to get a whole number because these are also approximations. So there's nothing wrong with decimals because no model is going to be so precise. You know, we round. We do the best we can. So here's x equals 2. Now what does that tell us? We're going to produce 2 cups of lemonade, or we're going to, you know, per, that's kind of a sad answer, but maybe it stands for number in hundreds, like number of units in thousands, or in hundreds, or in thousands. So 2 is really 2,000, or 2 is really 200. Okay, so 2 is looking like a good number for us. But let's say you didn't know that this couldn't be an answer, or let's say they were both positive. Now what your professor, your teacher probably has you do is something called the first derivative test. You put these numbers on a number line. Make sure you're paying attention to which one is smaller. It goes on the left, and the bigger number goes on the right. So this is called the first derivative test, and really you're going to test something inside the first derivative, and all we care about is if it's a positive or a negative number, because your first derivative is a rate or slope. And sometimes they call it a marginal cost, and maybe there's a little line drawn above it. So if I picked a number between these two numbers, let's start there. I'm going to pick 0. If I pick 0, and plug it in. Now you could fill it in here, here, or here. Being that I never divided by a negative, I'm not going to mess up my sign. I'm going to fill it here. Or you could, and you'll see 7, because that'll fall off. That'll fall off. 7 and -2, I get a negative. I get -14. I don't care it's -14. If I plug it in here, fall off, -14. If I plug it in there, gone, -84. No matter what way you do it. In your first derivative, you're going to get a negative number. That means your graph will be going down from -7/2, that x value, until 2, that x value. Now, here's the next thing. If the exponents are odd, some of you might know this, if the exponents are odd, that means that you have opposite behavior at the 0 determined, or critical number determined by that factor. That means that if this is negative, that has to be positive, and that has to be positive. But if you don't know about odd and even exponents in degree, then you're going to continue to do what your teacher told you, and you're just going to happily plug in the numbers and waste your time. But if you fill in a number like 2, on the other side of 2, so 3, I don't care what the answer is. 3 minus 2 is definitely positive. 2 times 3 plus 7 is positive, and a positive times a positive is positive. So that means my graph will be increasing after the 2. And then here, -7/2 is -3.5. I'm going to do -4. 2 times -4 is -8 plus 7 is negative, and -4 minus anything is negative, and a negative times a negative is positive. So what does that tell me? My graph is increasing, or my cost is increasing until x equals -7/2. So you would say that from -infinity until -7/2, close parenthesis, a union symbol. When else is it increasing? From 2, with a parenthesis because it's not including those numbers, comma, infinity, close parentheses. That's when we're increasing. And we are decreasing, oh boy, I don't have room. We are decreasing from, and always from left to right, -7/2, oh, why is that so big, until 2. What else can we tell? That means your graph is going up until -7/2, then your graph is going down. What graph are we talking about? Your cost graph. And then your graph is going up. We want to know when we have a minimum. When are we going to minimize the cost? Well, the cost minimizes when x is 2. Okay, that's how you proved that x equals 2 causes a minimum. Sorry, my dog's playing with his doll. So now we want to know, what is that minimum cost? You don't plug it in here. That's the rate of change of the cost. How do you find the actual minimal cost? You plug it in here. The cost function. Be literal. It's a literal equation. So I need to plug in 2. So 2 cubed is 2 times 2 times 2. I promise it's not 6, it's 8. 8 times 4, 32. So over here, we have this thing called function notation. It's super helpful because it helps us stay organized. You know which function you plug things into. So c of x equals 4 times 2 to the 3rd. I'm so sorry. Plus 9 times 2 to the 2nd. Running out of room here. Minus 84 times 2. Minus 168. All right. Oh, well, there's my issue. Dallas, shh. Go put your toy somewhere else. Oh my gosh. C of 2. Okay. Ooh, I'm totally cutting off. I'm distracted with my dog. Hold on 1 second. Pausing. Okay, sorry. Sorry, I was cutting it off as well. So I'm filling in 2 into my cost function, which is really this one right here. Everywhere I have an x, I swapped it out for a 2. So if you keep writing C of 2, then you know the cost when I produce 2,000 units is what? 2 to the 3rd is 8. 8 times 4 is 32. Plus 2 squared is 4 times 9 is 36. Negative times, ooh, I really want to change this problem because I meant for it to work out differently. Okay, ready? Don't get mad at me. We're going to go all the way to the beginning. I made this up on the fly, so make that a plus sign. Then make that a plus sign, make that a plus sign, make that a plus sign. And now it's like that never happened. Make that a plus sign. At this separate here then. Okay? So now this is negative, see what I did there? Negative 168 and positive 168. My intention was for it to fall off, but mental math, my dog's distracting me. Please forgive me. C of 2, the cost when you produce 2,000 units is $68 million. $1,000. Whatever it may be. Okay? So that is your minimal cost. That is the number of units you need to produce. Now, one more side example. Or actually, let's rewind a second. Factoring. Basically, you're looking for two expressions that multiply to give you that, two expressions that multiply to give you that, and while simultaneously having the outer and the inner give you that. Now, there is a real method behind factoring. Maybe that'll be enough to ring a bell. If not, I have videos posted on factoring techniques, so you could definitely check those out. Algebra videos on solving polynomials. So you just have to find this on the channel, and those should be able to help you. But one more thing. What happens when something is not factorable? Okay? It doesn't mean you can't solve it. It doesn't mean not solvable. It just means not factorable. So let's pretend for a moment that instead of the problem being what it was, okay, 2x squared plus 3x minus 14, let's say that that minus 14 was a minus, I just don't want it to accidentally end up being factorable, minus 6, okay? So let's say I have c prime of x was equal to 2x squared plus 3x minus 6. And you're like, okay, I'm going to try to factor this. So you're like, all right, I got 2x and x because 2 is prime, so easy. Oh, duh, not even showing it. Sorry. 2x and x. Okay. Now, what multiplies to give me 6? So I could do 1 and 6. So that'll be 12 and 1. That doesn't make 3. 6 and 1. If I put a 6 and a 1, I'll get 2 and 6. That gives me 4 or 10 or 8. Definitely doesn't give me a 3. What about 2 and 3? So if I did 2, I'd have 8 and 3. It gives me a 5. If I did 3, that's a 6 and 2. That doesn't give me 3. So what happens? If you don't remember, when something's not factorable, you really normally, it's called solving by completing the square. And then somebody got tired of completing the square and they're like, hey y'all, I'm going to complete the square one final time and I'm going to solve for x once and for all using letters. We're going to say hypothetical. This is an A, that's B, and that's C. And we ended up with this thing called the quadratic formula. Sound familiar? X equals negative B plus minus the square root of B squared minus 4AC all over 2A. I could definitely derive this for you. I'll do that in a separate video if you want. X equals, so now we fill in. Here's A, here's B, here's C. Okay? So X equals negative B, negative 3, plus minus the square root. B squared, 3 squared, I'm going to skip a little bit, 9, minus 4, A is 2, C is negative 6. So this is all being multiplied, 1, 2, and 3, okay? All over, make sure your square root or your fraction bar are all in the right place. 2a, which is 2 times 2. Continuing, x equals, an x right there, negative b, so can't do anything with that yet, plus minus the square root. Okay, so I have 9, that's I always like to do the big numbers first. So it's 24 times 2 is 48, but it's a negative and a negative, so it's a plus 48. 9 plus 48. Well, 10 plus 48 is 58. So 9 plus 48 is 57. So 57. If you have to pause and look at it again, then pause and look at it again. All over 4. Now, is the square root of 57 bigger than 3, or negative 3, or smaller, or even 3? Like if I do negative 3 plus the square root of 57, square root of 57 is going to be 7 point something. Square root of 49 is 7. Square root of 64 is 8. So if I do a negative 3 plus 7 point something, I'm going to get a positive number. Divided by 4, it's still going to be positive. But if I do negative 3 minus this number, it's definitely negative. Divided by a positive is definitely negative. So one of these could be the answer. Now if you don't have a calculator, you use the exact same logic I used initially. Okay, you have to know that if the function was a positive polynomial, it's going to finish pointing up. Okay, and if it has two critical values, that means it has two places that have a horizontal tangent line. So if I had a similar situation and it started with a positive, only if it started with a positive leading coefficient, you know it looks something like that. This spot equates to the x value, the smaller one, -3 minus the square root of 57 over 4. And then this one equates to the x value, -3 plus the square root of 57 divided by 4. Okay? Those are the x's. How do you get the cost? You take one of these big, ugly, disgusting numbers, okay, and probably a calculator, but whatever, and then you'll fill it in here. But what could you also write? If you were asked to do this without a calculator, and someone asked you, well, what's the cost? I wouldn't even completely fill it in. Be smarter, think smarter, not harder. The maximum, or minimum rather, I'm looking for the minimum. The minimum cost would be the C of, so that's the parenthesis like f of x, C of 2. The C of -3 plus square root of 57 all over 4. My dog is on his phone up and down the stairs. Oh my god. So there we go. So that is the cost, and that is the number of items or whatever that we need to produce to minimize the cost. But that's because you have to build your understanding. Sorry this video is a little crazy and scattered. Sorry about my barking dog. You have to know the quadratic formula. It only works on quadratics, hence the name quadratic formula, and not cubic or quartic or quintic formula. Okay, so it only works on this. Factoring techniques, these are from algebra. You could even factor things that are bigger than this using grouping method. Synthetic division can come in handy, rational root theorem. There's a lot of different things you can use, and I definitely have videos on that in my algebra folder. Okay? Best wishes.